Okay, cool. All right, welcome to our third session of the Learn and Grow series brought to you by the Lost Cat FUD Club. For this session, we're going to be talking about smart contracts. What are smart contracts? Quick high-level introduction. What are the differences between smart contracts on Ethereum, on Solana, how they're built, what you can do with them, and just generally a quick, high-level 101 course on getting people acquainted with this term. Now, smart contracts, you may have heard this term being thrown around pretty much everywhere in the Web3 spaces, not just in the NFT space, but around DeFi, even metaverse people, they talk about smart contracts too as ways of doing exchanges. But what exactly is it? So first of all, a smart contract, it's kind of like a traditional contract in that it serves as an agreement between two parties. It's a transaction. It can contain different terms, conditions, and basically anything that you would normally encode into a normal contract using words, you can encode into a smart contract using code, as in a programming language. And the really neat thing about a smart contract is this, because it is code that's executed on the blockchain, there is no, did they agree to perform this contract, yes or no? There's no question of that. It's really a very, very binary thing. Did this code execute? Did it do what the code said it was going to do? Yes or no? That's it. And, this is actually very ideal when it comes to contracts and agreements because there is no shades of gray. It's either did this piece of code run successfully or did it not run successfully? And so it's very, very clear if the terms have been met and this contract has executed versus the terms have not been met and this contract has not executed or not executed successfully. And the best part about all of this is because it's on the blockchain, it's totally transparent. Anyone can go and look at the transaction and verify that, yes, this was the contract that I thought it was. It really did execute. It executed against these accounts or against these coins or whatever. And it's very, very auditable. And due to the nature of the blockchain, it's also pretty secure as well. So in summary, a smart contract, think of it as a digital version of a traditional contract that's written using a programming language and that's executed on the blockchain. What are smart contracts used for? Frankly, they can be used for almost anything under the sun that involves two or more parties. The most common things that it's used for in the Web3 space these days are in DeFi, in terms of people lending, people collateralizing their assets, securing mortgages against them, staking, the whole gamut of DeFi scenarios. Decentralized apps as well. For instance, all of the apps around, hey, I want to mint an NFT. I want to play a game on the blockchain. I want to, trade and breed my crypto kitties. Those are all powered by smart contracts as well. And because of the way that smart contracts work and that it is very, very out in the open, it is auditable, and it consists of code that either executes or doesn't. It actually really helps simplify some traditional transactions today where we kind of require a neutral third party or an intermediary or an escrow to help facilitate the exchange of goods. The best example is buying a house. Today, when a buyer and a seller decide to buy or sell a house, they don't just do an exchange with each other. What happens is there is always a neutral third party called an escrow that is involved, and the buyer transfers their money to the escrow. And once the escrow has confirmed that that money is there, then they make the transaction and sign the house over. And that's really for security reasons, to make sure that, hey, the money is secure, the house, of course, the asset there is secure as well, and that the parties don't try to trick each other or nothing fails in between. You can imagine, for instance, if there wasn't an escrow, I would sign over the deed to my house first, and then you are attempting to pay me, but for whatever reason, the transaction fails. now what are we going to do? It's in a limbo state. I already signed over my deed to you. So legally, you actually have the house and you have your assets still. That gets pretty murky pretty quick. The alternate situation could be true as well. You send over your money. I tried to sign over the deed to my house. Turns out there's some lien on my house that I didn't realize. Some other bank or debitor has the lien on the house, and I'm legally not allowed to sign it over to you. A whole bunch of issues like that happen, and a transaction would have the risk of completing halfway, which is not an ideal state. And again, that's where smart contracts really come in handy, because there is no smart contract that can only execute halfway. It's all or nothing. And so I can transfer a lot of assets. For instance, I can buy a really expensive NFT, and I can be guaranteed that if this transaction goes through, I will have purchased that. If I don't have sufficient funds, or if the NFT holder has transferred or sold their NFT to someone else, there is never going to be a halfway state where someone has received funds or someone has transferred an asset without getting payment for it. That's an area where smart contracts are just clearly better than almost any other type of agreement system that we have today. And of course, the fact that this is all open, it's on the blockchain, it's verifiable, it's auditable, makes it even better, especially from an accounting perspective. Now, the thing to note when we talk about smart contracts is not all smart contracts are created equal, and in fact, not everything is a smart contract even. When we talk about smart contracts, because we're in the Solana space, the biggest place that we're going to be looking to compare ourselves to is Ethereum. And Ethereum and Solana actually have two completely different models for what a smart contract is, when smart contracts are used, and what smart contracts actually do. Most people, I think, they are more or less familiar, or if they're not familiar, the concept of a smart contract in their minds maps pretty well to what Ethereum actually does with smart contracts, in which what it means is almost every single type of thing that you're doing on the Ethereum network requires a smart contract, and you are writing a smart contract, which is, think of it as a little program, in order to do what you want to do. For instance, if you want to create an NFT and you want to allow people to mint your NFT, you're going to create a smart contract that sets the terms of what that NFT mint looks like, how you're going to receive payment, the mint authority that's going to create the NFT and send it to the buyer, all of that stuff, and it's encoded in a custom smart contract every single time. This is why when you go and mint an Ethereum NFT project, they often tell you, hey, this is the address of our smart contract. It's a little hash address. You click on it, and either Scan or some other blockchain explorer tool opens, and you can kind of see the terms and the details of how that smart contract works. Now, Solana is a little bit different. Solana, I actually think, has a superior model because what it does is not everything requires a smart contract. Solana has a concept of programs. Think of these as apps, kind of like apps on your phone. Instead of saying, hey, I want to mint an NFT, I want to launch an NFT project, so I need to write a custom smart contract, Solana says, hey, we know NFTs are a very common use case. We know there are tens of thousands of projects that want to mint. So what we're going to do is we're going to create an app. We're going to create a quote-unquote Solana program library app that's going to call the SPL Mint program. And this is, think of it as a pre-filled contract, right? Think of it as a contract template. I don't need to write the entire contract from scratch. I just need to fill in a few blanks that says, hey, what is my token? What is my mint authority? What is my destination? What is the cost? And then when this program executes, it just does whatever I need to do. It does the mint process. And the really nice thing about this model from Solana is it is incredibly just way more secure and easy to be trusted than what Ethereum's model is. The problem with Ethereum is you have tens of thousands of NFT projects. Very few of them actually have real developers that have audited and created secure smart contracts. Most of them are actually just copy and paste smart contract code from other NFT projects and open source examples without really understanding what's going on. And so you have these smart contracts that are not really very secure, have not really gone through any sort of vigorous, security best practices. Even from a gas and efficiency perspective, a lot of these smart contracts are not optimized in a way that actually minimizes the gas fees because they incur too many additional transactions. And so it's just not very efficient, it's not very secure. Solana, on the other hand, first of all, transaction fees nearly non existent, speed near instantaneous. But because you're not asking every single NFT project to create their own smart contract from scratch or copy a smart contract code from some random library they found, these are actually vetted first-party programs that the Solana developers run. And because it is a shared common program that everyone uses, it gets a lot of oversight. There's a lot of security best practices being applied. There's a lot of people, trying to break the code and realizing that, hey, there's bugs, and so we can fix the bugs. And so it's a central code base that really, really can get better over time and get more secure over time. And so this model works very well. On top of that, if you want to do totally custom things, you can still do that with Solana. And what you need to do is you just write your own quote unquote custom program. That's effectively you writing your own custom smart contract. And so basically the biggest difference here is Solana balances simplicity with flexibility. Simplicity and security of having a first-party set of programs that run natively on the chain that's built by the Solana engineering team, and then the flexibility to run your own custom programs if you want to do custom things. Whereas Ethereum kind of doesn't give you that. Ethereum just says, hey, everyone, go write your own smart contract, and just lets people do it. So just to keep in mind, these are probably the biggest differences across chains. When we go talk about other chains, for instance, Near or Chronos or other L1 chains, they all have various different stories that set themselves apart in terms of how smart contracts work and how they're executed as well. It gets pretty technical pretty quick, but since we are a Solana-based project, and since Ethereum is the most popular smart contract chain, I think these two are probably the most relevant ones to talk about. Whoops, this is an extra slide that should have been removed. This was about staking. But staking is also a smart contract. And the thing about staking is, depending on which staking platform you're using, some of them are using a combination of first-party Solana programs. Some of them are using a custom staking contract that the engineers have developed on their own. So it's good to have some idea of how smart contracts work so you can really understand the mechanics of how staking works. A lot of the times when it comes to staking, like I said in the last Learn and Grow session, there are many risks, and the nature of these smart contracts and how they're implemented is one way that some of these risks can manifest. Again, especially if the developers are creating their own custom smart contracts, and if these developers are maybe not the most seasoned developers, or maybe they just haven't had a lot of experience with security best practices when it comes to blockchain or Solana, this is an area where potential vulnerabilities may exist. Worst case, it may be a severe vulnerability, kind of like the whole wormhole exploit where somebody realized, hey, I can basically print unlimited money and steal everyone's assets. Or it could be something benign, such as, oh, hey, if XYZ conditions occur, I may not get the right payout. There's a whole bunch of, because it's programming, it's machine code, there's so many different branches in the logic that you really do need to have a fairly technical team who is very security minded to be able to build these in a safe, scalable, and secure way. And finally, we're getting a little bit technical here. For those of you who have a little bit of programming experience, a diagram like this probably looks familiar. For those of you who have never wrote a single line of code in your life, this probably looks crazy complicated and you have no idea what it is. Let me just start by kind of simplifying this a little bit. So this is talking about how smart contracts, aka Solana programs, work on the Solana blockchain. And what a program is it's basically some code that is written, and that in Solana that's generally written using Rust, although it's technically possible to use C and C++ as well. And once a developer writes this program and they write it on their local machine, kind of like how they would develop any other type of app, they deploy this program to the Solana network. Now, generally developers, they don't deploy directly to the Solana mainnet because the mainnet uses real Solana coins and it does real transactions against real wallets. Generally, what developers do is they write some code, they deploy it to a test network, they test the code, make sure it's all good, and then once they feel confident, then they deploy it to the Solana mainnet. And now once a program has been deployed to the Solana mainnet, it's now accessible by any type of client that's talking to the Solana network. And so a client can be a command line interface, which is basically that black terminal dialog that you may see sometimes. But most commonly for end users, a client is an app. It's, you go to some website, you sign in, you connect your wallet, and then you can do something. That's called a client. And what these clients do is they go and talk to the Solana network. There are various different services that act as portals or gateways to the Solana network. These are what we call RPC, which is remote procedure call endpoints. And it's basically, think of it as an on-ramp into the Solana network. So you go to a website, you connect your wallet, and then your browser is then making a call to one of these on-ramps. And one of these on-ramps is basically just translating the JavaScript, whatever transaction or query that your client is issuing, into a request that is sent to the various nodes or validators on the Solana network itself. And so now you can create transactions, you can query the Solana network, and you can do all of these things that allow you to execute programs, transfer SOL, mint an NFT, do whatever it is that you want to do with Solana. So that's generally how this entire model works. Now, the important thing to realize here is two things. One is you're never talking directly to a developer in terms of what your browser is doing. Your browser is always going to be interfacing directly with Solana. And that's actually good. That adds a layer of security because generally people can have a level of faith and trust in the Solana network that it's going to do what it says it's going to do, that the endpoints that are on-ramps to the Solana network are pretty legit, versus having to trust a totally random developer who wrote a totally random program that you don't actually know where exactly they're running. Is it actually hitting the Solana network, or is it just hitting some fake web service pretending to be a Solana network? So because in this diagram, the clients are never talking directly to the developers that are writing the program, they're always talking to Solana. Again, that adds a level of security to the architecture. Now, I know that was super, super complicated. For those of you who may not come from a technical background, we can follow up more. If you have any questions, feel free to send them my way, and I can probably do a better job explaining this. But I hope this gives you just a little peek into some of the technical architecture of how this works. Finally, here's a few links to some resources. If you're ever interested in just dipping your toes and playing with smart contracts on Solana, there's actually a few tutorials that if you are good at following directions and if you have a fairly basic working knowledge of, for instance, editing text files, running command line commands, you can probably get started and familiarize yourself in a matter of hours. And so it's a pretty good way to just start learning the basics of how to build on Solana. And then finally, I'll leave you with the slide that's always our last slide. Again, just a reminder about the two biggest things that are going to be affecting everyone: security and taxes. Of course, security, always be careful, always be on the lookout, especially for phishing. Taxes, of course, don't forget about taxes, especially since it's tax season right now and they're going to be due in a few weeks. Make sure to not ignore your NFT taxes. Make sure to not ignore any sort of staking rewards or airdrops that you get. Just make sure that you're compliant. It's always going to be easier to do it now than try to catch up and do it after you get audited. So better to play it safe. And with that, I want to conclude our third Learn and Grow session. Thank you very much. If you have any questions, again, feel free to drop by our Discord, send them my way. Have a great day, everyone.